Hello everyone, welcome to another factory visit. This time we are up north in Italy near Bergamo at a company that everyone knows. You can already see it in the background. Today it's all about Brembo and how they do things here, what goes into it all. That's exactly what we're going to find out now after the intro. So here we are already inside the Holy Halls, at the very first station where things get serious in the development of all the products. And how that process works is what we are going to take a closer look at now. Right here we've got the first area where quite a few people are racking their brains. How can we improve parts of the braking systems or make sure they meet the demands of our customers? As you can see, it's not just 2 or 3 people working here. There's a proper team trying to solve these problems. They've got some very good computer systems in place, and of course there's a strong reliance on computer-aided design, also known as CAD, which already provides a lot of support at the software level, helping to save valuable time in the product development process. Unfortunately, we're not allowed to get too close because, of course, a lot of what's going on here is top secret. The clients, meaning the vehicle manufacturers who develop their systems here, naturally want to keep their innovations under wraps. So we're only allowed a quick look from the outside. But we'll move straight on to the next interesting station where it's all about testing the various products using the corresponding test benches. We are now at the first station where the fundamental functionality of the individual systems is checked. For example, right in front of us here is a system that can check the run out of brake discs. The brake disc is placed here, and using a dial gauge, the entire disc can be measured to see if it falls within the tolerances and whether the run out is acceptable. If we head a bit further to the right, now here we already see another setup that can measure the brake caliper and test its basic function. The point is to get the pistons moving inside the caliper, and you also need to check whether the pistons reset properly, and this setup is perfect for that. The hoses are already connected here so that the system can be pressurized with brake fluid. What they are doing here is verifying whether the system's basic function is working correctly before it's sent off to the real test benches. We've been talking a lot about braking systems and brake calipers, but what exactly goes into them? Well, here we can get a proper look. We've laid out all the individual parts of such a system, so let's take a look at what's hidden inside. First, we've got the brake caliper. Everyone's familiar with that. Then we've got the brake pads, also well known. There's a small spring at the back which, once installed, and we'll see this later, helps to keep the brake pads stable so they don't start fluttering. That's because the pistons retract slightly after braking, and if there's too much play, it could cause juddering or noise. That's where the clip comes in. The pistons themselves, as we can see here, have special coatings. The aim is to allow them to move as smoothly as possible within the caliper, working in tandem with the appropriate seals. And this combination needs to meet certain standards to ensure the braking performance remains consistent across a wide range of temperatures. Now we are already at the next station where the different products, primarily the brake calipers, are subjected to various climate conditions. What we've got here are climate chambers where we can simulate loads in terms of temperature and humidity, because we all know bikes are used all over the world in humid, dry and very hot regions, and this setup lets us replicate those conditions. The components stay inside these chambers for several days, and afterwards you can see how the materials behave.
Unter solchen Bedingungen verhält.
Now at this station, it's the brake master cylinder that gets put to the test. A cylinder applies force to the brake lever to see how the system behaves, both the master cylinder itself and in conjunction with the lever. On the screen here, you can see the stress patterns that are being simulated and checked. This process runs over a certain period, several days or several hours, depending on what exactly is being tested. And at the end, they check how much wear has occurred, the degree of wear basically. That already tells you a lot about the functionality and durability of the system. Once all of these static tests have been completed, we move on to the next stage, which is the dynamic testing. And as you can see, there are test benches on both sides, where the systems are pushed to real operating temperatures and scenarios. For example, the disc is mounted onto a spindle, rotated, and then actively engaged by the caliper. All the parameters are logged during this process. Looking at the labels, the dynamic braking capabilities here can reach up to 2,500 revolutions per minute and braking torque of up to 5,000 Newton meters. We'd love it if some engines could deliver that kind of torque. They can also simulate different climatic conditions here. The engineers sit and evaluate the quality of the product, checking how well it holds up under stress. And what's tested here is not just the caliper alone, but the entire system. Caliper, disc and pads working together as a unit. Once everything on the test benches checks out and passes inspection, the components are then trialed directly on the motorcycles. There are special test setups for this, of course, and they include integrated data recording systems. What we're looking at here is a system from 2D, currently being fitted. It's all about capturing key parameters. For example, as we see down here on the caliper and the disc, the temperature values. Naturally, they want to understand how everything behaves during actual use. Temperature is one of the most critical factors in braking systems. It must stay within a certain operating range, and that's precisely what they're checking. Beyond that, the system even goes a step further. They can also monitor what's happening at the brake master cylinder. Let me just walk around for a second. There's also a dedicated angle sensor on the brake lever itself. So the data recording system can show what the rider is doing, how hard they're braking, and how the brake system is responding under load. That provides essential information when it comes to giving the green light for mass production. And if they find that something's not quite right, say a caliper or disc isn't behaving as it should, they can take a step back and return to the test benches. Because the benefit of a bench test is that you can focus very specifically on a problem without external variables from the rest of the bike interfering. So this back and forth between bench testing and real-world riding is key to refining and perfecting the brake system. And Brembo, of course, doesn't just work on motorcycles, they're heavily involved in the automotive world too. As you can clearly see here, they've set up a small gallery for us, and it's immediately obvious that some of these parts aren't meant for bikes, they're far too massive. For instance, here's a brake system from Ferrari and next to it one from a Range Rover. The sheer size of the components compared to motorcycle parts is striking. Plus you'll notice the signature colors. The red caliper in particular is a hallmark of Brembo, something many of you will recognize. That's really their trademark. And clearly some of these systems are built on a much grander scale. Now we get a little glimpse into the future. How will braking systems work down the line? What we see here is a prototype installed in a car. The calipers and discs themselves won't change dramatically, but the way they are controlled certainly will. Up until now, braking has been managed through a hydraulic system, and the ABS module takes over if there's too much braking force. Here the brake is still operated via a pedal, as you'd expect in a car, but instead of the braking force being transferred hydraulically, it's transmitted electronically. This is what's called brake-by-wire, similar to ride-by-wire, which we already know from throttle systems, where the throttle grip is no longer mechanically connected to the engine, but is managed by a computer. And the same approach is likely to be applied to braking systems in the future. The big advantage of this is that the usual pulsation you feel when the ABS kicks in That won't be there anymore because the system is entirely decoupled. We do still have ABS functionality integrated, but it's transmitted entirely via electronics. Over there you can see the control unit, another of these systems integrated into the vehicle. But the huge benefit is that the modulation of the ABS is no longer felt at the pedal thanks to that decoupling. On top of that, you can also tailor the response of the braking system to your preference by adjusting the relationship between the brake pedal and the actuator, which is shown here. The brake calipers are no longer actuated by hydraulic pressure, but instead by electronic actuators, which are triggered by the system. Another benefit of this is that you can control the braking force at each wheel independently, applying different levels of braking pressure to each wheel within an incredibly short response time. That makes it possible to fine-tune the braking effect of each individual wheel precisely, which opens up a whole new level of performance and safety. And shortly after stepping into these sacred halls, we arrive at the first exhibition area where Brembo gives us a quick overview of their journey so far. Brembo has been around since 1961, although they didn't actually start out in brake system development. Initially, it was just a regular mechanical workshop. Over the years though, and thanks to a bit of luck, they gradually moved into the braking sector. As we can see here, the company's roots go back to 1961. Back then it was just a small outfit machining basic parts. Then by 1964 they started to produce the first brake disc for the aftermarket. And in 1972 they began supplying braking systems for their first vehicles. That's when things started to pick up, and when a Ferrari Formula One car was fitted with Brembo brakes in 1964, things really took off. That's when Brembo became widely known as the brake manufacturer. And if we keep going along this timeline, we can see just how many successes Brembo has celebrated. Just looking at the wall here, you'll notice there aren't many years missing when they didn't win a world championship. In both car racing and bike racing, NASCAR, World Rally Cars, they've been involved in it all. And they've rarely missed a championship-winning team. It's seriously impressive. If we wait a bit longer, we'll get to our favorite section, the motorcycle side of things. MotoGP, superbikes and even off-road and motocross. Brembo has had a lot of success there too. The history displayed here is pretty unique, and it shows just how much innovation Brembo has brought to market over the decades. We've even got a visual showing the kinds of loads these braking systems are subjected to. As a former pilot, I was personally thrilled to see that they even referenced aviation. Not because Brembo is actually involved in that field, but just as a way to illustrate the extreme forces involved. Still, it was nice to see that crossover. And now we come to one of the real highlights, carbon braking systems. These have become increasingly common in recent years thanks to their ability to withstand massive loads and deliver extreme deceleration values. This here is probably the most interesting bit for us. It's an actual MotoGP braking system exactly as used in the championship. You'll notice that the brake ring is made entirely from carbon material, while the inner star, the part it's mounted to, is made from lightweight aluminium. The two are connected via floating elements that allow for a bit of movement. And even the brake pads, hard to believe, are made from carbon too. This combination produces the right coefficient of friction and gives the braking system the consistency it needs. The aim is to maintain constant braking performance and pressure across an entire race distance. And in that respect, the carbon setup is currently the gold standard.
Absolvieren zu können. Und da ist das Carbon-System das Maß aller Dinge heutzutage.
Color has always played an important role for Brembo. As you'd expect from an Italian company, design is taken very seriously, and that includes brake systems. That's why they've showcased here just how important color has always been for the brand. The classic shade for calipers, as many of you already know, is of course red. It's even more widespread in the automotive world. On motorcycles, red isn't quite as common, but among car manufacturers, the red Brembo caliper is a favorite, as it stands out beautifully through the wheel arches. Here, for example, we can see a Ferrari caliper with the matching carbon ceramic brake setup. That's exactly how it should look, with the Brembo name front and center. Now, for someone like me with a background in mechanical engineering, what's most fascinating is seeing the manufacturing process up close. And here we've got a really detailed demonstration. You can see just how precise the machining needs to be and how much detail has to be milled out. What we're starting with is the base material, essentially just a solid block of metal. From this block, through various stages, the final product is created.
You've really got to picture it.
The final caliper you see here actually starts off as nothing more than a cube of raw metal. So you can imagine how many steps it takes, how many machining operations to transform that into a finished caliper. And of course, that's one of the reasons why these parts come at a certain price. Not only does the machining require time, but the quality of the material matters too. And so does the quality of the machines used. These machines need to meet extremely high standards to work with such high-performance components. From a mechanical manufacturing perspective, one of the most interesting things is these little pins and stops that have to be precisely milled from solid material. That process is incredibly demanding and time-consuming and needs to be done with extremely high-quality tools. And when you look at the finished product afterwards, I must say I'm absolutely blown away.
Right then, as I promised earlier, we're now heading into the really secretive halls, the hidden kit used in racing. And here's where things get especially interesting. We are talking MotoGP and superbikes. What's currently being used on track is what we are about to take a closer look at. Right here we've got a brake disc from a current superbike, and you can already spot a few special features, like these little fins around the edge. They are designed to provide extra cooling, acting like heat sinks to help with thermal management. There's a similar system on MotoGP bikes as well. In fact, this concept was developed originally for MotoGP. If you look closely, you'll see the same type of fins for cooling purposes, although the ones on the GP version are noticeably larger. What's really impressive is just how light this brake disc is. Obviously, it's hard to show that on camera, but this disc weighs about half as much as a comparable steel one. It's paired with carbon brake pads, which, unlike regular pads that have a metal backing plate, are made entirely from solid carbon and act directly on the carbon disc.
To go with that, of course, you need a matching brake caliper. Here we've got a current MotoGP caliper, exactly as it's used in the championship. And once again, you'll notice these cooling fins, which have to be milled straight from solid material. They are all around the caliper to help dissipate heat.
If we take a closer look inside, you can also spot the carbon brake pads fitted inside.
And there's a clever little trick going on here that's worth pointing out. You'll notice a small angled edge on the pads themselves. That angle actually enhances the braking effect. Here's how it works. When you apply the brake and the pad is pressed against the disc, friction causes it to shift slightly forward. Thanks to the angled edge, this movement increases the pressure between the pad and the disc. It's a kind of self-reinforcing effect. Both pads have this feature, and it gives the rider additional support by reducing the braking force needed.
And for the telemetry fans out there, here's something you like. This is a brake master cylinder equipped with a travel sensor, just like the ones we saw in the test department. But this one is actually mounted on a working race bike. It allows the rider's brake lever input to be graphically recorded and matched with deceleration data. That way, if the braking performance starts to fade, it's clearly visible in the telemetry data. So by now we've heard a lot about carbon being such an incredible material for braking systems. Naturally, the big question is, if it's so great, why don't we see it used on all production bikes? Well, that's exactly what we're going to ask our expert, Matteo.
We saw a lot of different and interesting things, especially carbon brake systems. We hear a lot about the advantages of the carbon brake systems. Why don't we see them on normal road bikes?
On normal road bikes will be very difficult to handle this kind of material, because carbon material works perfectly in a certain range of temperature. To keep this kind of temperature, you need to hard brake very often. So you can use this kind of material only on a race application. If you use this on a road application, it will be very, very difficult to keep the temperature on the perfect range. You will feel like there is no friction coefficient on the brakes. This is why it's not relatable for a street application.
Makes sense. And how about the costs? Are the costs also a big different factor between those systems?
Yes, of course, cost is also another value, because if you think about it, the carbon material need at least between 8 or 9 months to build up the correct density of the material. You understand that there is a big difference compared to steel brake disc.
So now we know why we are unlikely to see carbon brakes on production motorcycles anytime soon. And even though it's quite loud in here, we've now reached the section where the automated production of monoblock calipers takes place. Let's have a look at what happens next, because machining is only part of the story. The surface also needs to be treated properly to ensure durability over time. And here at this station we can see exactly how that's done. These fully machined calipers are mounted onto racks and then dipped into a bath to begin the surface finishing process. Depending on the type of bath, different colors can be achieved. A current is passed through the bath, which triggers the anodizing process. And here you can see the finished calipers, ready in a range of colors depending on the motorcycle manufacturer's preferences. Manufacturers can choose between gold, silver, titanium tones or black finishes. It's entirely up to them how they want their calipers delivered.
So far we've seen a lot of highly automated systems, but when it comes to finishing, particularly one of the most important details, the Brembo logo, things are still done by hand. And here's how they do it. After a long walk, the site really is impressively large. We've now reached the next hall, where the following stage of production takes place. Here we can see, for example, how the monoblock calipers are milled and processed. This is a bit of a speciality, a kind of secret know-how from Brembo, how they manage to machine a closed system from the inside. It's very specialized knowledge, and Brembo is pretty much the only company that has it. That's why, to be honest, they don't really have any direct competitors in this area. Brembo has a clear, unique selling point here. Let's get a bit louder inside, so I'll give you a quick summary of what we are going to see. It's not just about machining, we've also got the surface finishing, because of course when a part is machined, it just has a bare surface with no protective treatment. That surface would naturally start to degrade over time. And that's exactly what we want to avoid. That's why there are additional finishing steps like anodizing, which we'll take a closer look at in there. But I'd say instead of talking about it too much out here, let's just head in and see for ourselves. And right as you step inside, you immediately see how big this place is and how highly automated the processes are. There are robotic handling machines here controlled either by PLCs or full computer systems. In the back part of the hall, we've got the surface treatment area, and over on the far side, the machining of the monoblock calipers continues. There's a lot to take in. Now that the individual parts have been fully machined, we're moving on to the next station, where all the components are assembled. And let's have a quick look at how that works. It starts here fully automated. The young technician takes the part out and brings it to the next station, where the seals are inserted to ensure the caliper is properly sealed between the pistons and the housing. The team working here are really quick. They've got it down to a fine art. Then we move along to the next station.
Dann kommen wir weiter zur nächsten Station.
There everything is checked again, some pins are added, and the technician here does the following. She checks whether all the seals are seated properly. Then the pistons are next. The pistons are pre-coated with a specific lubricant to help them slide in smoothly. And now she's completing that step. We'll just wait a moment while she finishes. On the other side, and now she presses the pistons into the caliper.
And just like that, she's done. Extremely efficient, really. At the next station, the caliper is pressure tested. You can see how it's pressurized so that the pistons push out slightly, and this allows them to check whether the sealing is effective. Once this station is complete, we can confirm that the caliper is fully functional. Once that's been done, as you can see, the technician removes the caliper. It moves on to the final station. Here's where the last few assembly steps take place to complete the product. For example, the clips that hold the brake pads in place are installed, along with the pads themselves. Even here, the process is closely monitored. There's a dedicated camera system that takes a photo of each caliper and checks whether every single component has been correctly installed. That means we've got a 100% quality control check. No part can accidentally be shipped out with a defect. It's a rock-solid setup. Up until now, we've mainly been looking at calipers, how they're made, how they're assembled, but now let's take a look at how things work with the master cylinder. Just like with the caliper earlier, there are specific stations here where the individual components are assembled into a complete unit. And of course, the most interesting stages are found at the end again. Here we have the finished master cylinder being clamped into place so its functionality can be tested. A cylinder applies pressure to the lever and the connected part is then checked to see whether the proper braking pressure is being built up and maintained. And at the very end, there's a final camera system in place, just like before, which takes a photo of the assembly to check that every single part has been correctly installed. If anything is missing or not right, an alarm is triggered automatically and the entire part is returned to the production line for correction. So, after seeing just how highly automated the entire process is here at Brembo, we come to the next assembly step, this time for the rear brake caliper of a well-known motorcycle brand. You can see how many robotic arms are already in use here. They used to connect one production step to the next. The whole process runs completely autonomously without human input, which not only saves costs but also speeds everything up since every step is perfectly synchronized. Just to touch on a few extra points, since the whole visit has been quite fast-paced and we couldn't access all the most interesting areas, it's important to understand that Brembo holds an immense amount of know-how, and of course they're not keen on sharing every technical detail with the public. That said, I have to say it's all incredibly impressive. One thing that stood out to me in particular is the fact that Brembo now operates on a truly global scale. That's not exactly breaking news, but they've got production sites and facilities in several different countries. What's especially striking is that at every one of those locations, Brembo is capable of handling the entire process, from development to final assembly, particularly here in Italy where the headquarters is based. The full cycle is covered. It all starts with an idea, often coming from OEMs, that is, motorcycle manufacturers, who approach Brembo with specific requirements. From there, they collaborate with Brembo engineers to come up with solutions which are then translated into CAD models and developed into physical prototypes. These get tested, and if everything works as it should, they are put into production. Brembo offers this full service package to any motorcycle manufacturer, no matter the brand. Because of that, they are understandably protective. If they've developed something specific for one manufacturer, they obviously want to keep that away from the competition. That's one of the reasons it wasn't easy for us to get a detailed look at every area. What's also interesting, though again not really news, is how deeply involved Brembo is in motorsport. And the amount of knowledge they gain from racing is enormous. They've got dedicated staff who work directly with racing teams in various disciplines, whether it's MotoGP, Formula 1, NASCAR or others. And these team members gather feedback and issues from the racetrack and bring them back to the company for further development. That constant feedback loop is crucial for staying at the cutting edge, and it's something I personally find really exciting. Another fascinating point, Even just a few years after founding the company, Brembo was already thinking about how to integrate systems that are closely related to braking. So much so that they began acquiring companies who made those systems. One major acquisition was Marchesini. That name will definitely ring a bell for most of you. They're a well-known manufacturer of motorcycle wheels. And this was an important step for Brembo because they've never seen the brake system as something isolated. It's always been about the complete package. So bringing Marchesini into the fold made perfect sense. After all, a brake disc isn't a standalone component, it's mounted to a wheel. And if you got control over the wheel design as well, because you manufacture it yourself, that gives you a massive advantage. You can tailor the wheel precisely to the braking system. That kind of integration is a huge benefit. The next step, and you probably remember this from fairly recently, was the acquisition of Öhlins. That deal was finalized just last year. With that move, Brembo now has not only the brake and the wheel system, but also the suspension, and that of course forms another major part of the overall structure. It's all connected. What Brembo is aiming for here is to replicate and control as much of the motorcycle system as possible, so it's inevitably necessary to also have as many of the parts that belong to it in production and development. That was the thinking behind the decision to bring Öhlins into the group and involve them in development. It's still early days, as the integration only happened recently, but over the coming years, Öhlins will be more and more deeply involved in Brembo's product development. The ultimate goal is to optimize as much of the motorcycle as possible from within their own group. Now, since we've just mentioned Öhlins, I couldn't resist asking one last question, namely, what's the difference between Brembo's original equipment parts, the ones used on production bikes, and the ones we can buy on the aftermarket?
The answer was surprisingly simple. There isn't one. With Öhlins, for example, there are sometimes variations between OEM and aftermarket forks or shock absorbers with different levels of quality or spec. But that's not the case with Brembo. And I think that's an important point worth noting. At Brembo, the same products that are delivered to manufacturers for production bikes are also sold on the aftermarket, from the exact same production line. There's no difference in quality or specification. And that's partly because Brembo is already dealing with a massive issue, fake or counterfeit products, particularly on the Asian market. These fake calipers and parts are constantly popping up. Brembo now has to invest a huge amount of resources into combating this kind of product piracy. They've even set up a dedicated department to handle it. It's an ongoing battle. As soon as one counterfeit product is taken off the market, another one tends to show up, so the fight continues and the cycle starts all over again. Something else that really stands out when visiting Brembo is just how massive the whole site is. In fact, we had to drive from one facility to another within the complex. The distances are that large. It really brings home the fact that Brembo is far more than just a brake manufacturer, as people might assume. As we've already touched on, there are now many different brands operating under the Brembo umbrella. And when you take it all in together, it's genuinely impressive what they've built here, not just in the world of motorcycles, but also in every aspect of the automotive sector. And so, as the saying goes, in the end, it's the ones who brake best that come out on top. Now we've come full circle, back to where it all began. For me, and I hope for you as well, this has been a fascinating journey walking through the halls and seeing the entire process in action. I hope you enjoyed it, and I look forward to seeing you again at the next factory inspection. Right here, of course, with 1000 PS. Bye for now, and thanks for watching.